Okay. Welcome to Angular Nation. We're excited to bring you another free talk on our beginners channel today. Big shout out to our sponsors, AG Grid, for making this possible. And if you're interested in premium events, you can check out the experts channel where we have GDEs and other experts giving talks weekly. Today we have Jordi, who's going to give a talk of introduction to reactive programming. So I'll hand it over to you, Jordi.
Thank you. So let's get started. There we go. Let me know when you see my screen.
Yeah, we can see it.
Okay. So a small introduction to reactive programming in Angular. What we'll see today is mostly these things here. Obviously, we'll need to know what are the observables, how we approach that in Angular, how we are taught normally to use observables in Angular, better ways to use it with RxJS operations, and how to do it in a reactive way with the Async pipe, and the advantage it has, why we want to do it that way. That would be probably the first part of the speech. And we'll have a second part where I will try to introduce a little bit of subjects, or RxJS subjects, how they help us to make our applications reactive, and how to share data between our components in an easier and faster way and leaner way with the subject. So that's the overview. So we'll start asking if anyone knows what's an observable. Anyone knows? Anyone has a definition for observables?
I think Rob has.
It's basically a stream of events over time. So you are observing those events as they occur.
Okay, yes, that's quite appropriate. But I have a definition that helps us see that in a more, it's correct, the definition is correct, it's a stream of events that you're observing. But if you go deeper into it, what it really is, I have a definition that sticks in my mind if you have one sentence. That's this. An observable is an undefined amount of data in an undefined amount of time. Too much undefined probably for a definition, but bear with me. I like this definition because it says clearly what an actual observable is. An observable is an undefined amount of data because it might be a lot of data, or it can be none at all. You don't need to have data to have an observable. You can be just observing something to happen and never happen. Like imagine you have an observable based on clicks on the screen. Based how many times a user clicks on the screen. The user can click 1 time, 2 times, 500 times, like when you're crazy angry at the computer. Or you might not click ever at all, but you're still observing that. And in a defined amount of time, because that first click can happen right away, or it can happen like in 100 years. You don't know that. That's for me the way an observable works and why it has the problems or complexities it has. Since, for instance, in the final amount of time, if you have that running forever, you might have problems, right? So this leads to the definition that was said earlier to streams, right? When I think of observables and I think of streams, I was talking Angular earlier, I have this image in my head, the image of a faucet of water. When you need some information, you subscribe to an observable, you turn on the faucet. Like when you go to wash your hands, you turn on the faucet, wash your hands, and you turn it off. The same thing as observables. You need some data, you subscribe to it. You don't need it anymore. You need to unsubscribe. Why? For instance, if you do that with the faucet, if you turn on the faucet and you wash your hands, you walk away, you'll have a expensive bill of water and probably a flooded house. You don't want that. So with observables, it's the same thing. If you turn on the faucet, if you subscribe to observable and you don't unsubscribe, you'll have a high bill, also known as memory leaks, or a flooded house, also known as an unresponsive application. So that's are the problems we need to deal with when we're working with observables and working with streams. So, good, still here? Yes?
Makes sense. Yep.
Yeah, okay. So, when we first learn Angular and we learn to work with observables, we usually talk what's called imperative way. Imperative, the word imperative actually comes from Latin. I'm not sure if anyone knows that, but one of the most related words to imperative Latin would be imperator. An imperator is an emperor. And what does an emperor? Commands things, you do this, you do that thing, you do this, you do that. So it's the same thing with code. When you're using imperative ways of coding, you're telling every step of the way what the problem is to do. So it's very cumbersome because you're like micromanaging what you're doing. For instance, in this case, if you do it this way with observables, the first thing you think of, okay, I need to get my data, so I'll go in the OGen init and subscribe. And then, since you're a smart programmer, you think, okay, I need to unsubscribe. When you need to unsubscribe, you realize you need a subscription. So you create a subscription. And then TypeScript complains this subscription is not initialized. You need to do something about it. So you end up writing lots of code. So you have, because you're doing everything, you're marking every way of every step of the way, you're just telling the program and the language what it needs to do. So you need to be very specific. So this has a few cons. One is it forces too much extra code, as you can see. There's lots of things to do. And this is only one subscription. Imagine you have 3, 4, 5 subscriptions. You will need to declare each one of them and unsubscribe each one of them. That's not scalable, and also very error prone. You will end up, you're raising the probability to make errors the more lines of code you need to write that way. So the imperative way, as it says, if you write a subscription, you need to handle each unsubscription manually, and you need to declare 2 lifecycle hooks in order to do that. And it's not scalable, as I was saying, because you need to do it manually for each one of the subscriptions. There is a better way. It's called the declarative way. The declarative way is a good way to work with subscriptions if you need to subscribe to observable right away, because it's more scalable. But still, it's quite a big amount of code. You still need the 2 life cycles. You still need to initialize the subscription in the OGen init. You still need to unsubscribe somehow and then destroy. The advantage of doing this is here you're starting to use RxJS in a more detailed way, in a more proper way. For instance, when we get the results from the subscription here, we're using an operator which is called the take until. The take until allows the subscription to go on until the observable path inside emits. So that allows us to, in the OG destroy, make that one observable emit, and we close all the subscriptions in one go. Does that make sense? I guess. Yes?
Yes, it does.
Yep.
Yeah, okay. So that way, you can handle multiple subscriptions, and you just need to shut them down once, because when the destroy observable meets, so you're using the take and kill on every new subscription, you just kill them all in one go. You don't need to unsubscribe manually to each one of them. So that's a better way. It's more scalable than it was before. But still, it's quite convoluted. You still need to initialize a new engine unit. You still need to make the subject, which we'll later see why it's a subject, not that we have a subject, for instance. You need to make it a myth. So we still need to work inside of it. So Angular provides us with a better tool for doing this, and it's much leaner, which is the reactive way. And that would be using the Async pipe. At first glance, you can see right away that's much less code. It's much cleaner. It's still doing the same thing as the ones before. It's not doing one thing less than the others. It's just doing the same thing as the others. It's just being more reactive. So you just let the program let Angular do the things for you. For instance, you remember at the beginning I was talking about the water faucet. That you turn on the water, you wash your hands, you turn it off. You probably know that there are some faucets that are automatic. You put your hands under the water, it comes out, and the moment you remove your hands, the faucet stops. It's like automatic. So the Async pipe, I like to think it's something like that, it's similar to that, because it automatically subscribes to the observable when you need to, and it automatically unsubscribes from it when you don't need anymore, without you manually having to tell Angular when to do it. So that gives you lots of freedom, and at the same time avoids the possibility of making mistakes, because it does not depend on you, the human being, telling Angular when it needs to be done. Angular knows by itself with the Async pipe when he can do it. So you're gaining, for once, less mistakes, because you don't have to decide. Angular can decide for you better in that case. You need to handle the subscription, so you don't need to create them. You don't need to unsubscribe them, and you don't need the life cycles actually, because you just bind the observable in the component, the observable in the service, and you don't need to do anything else in this case, for instance. That's a very practical way to manage an observable. You just use that observable in the template with the sync, and that's it. So as you can see, less code, more effective, cleaner, and even with more advantages, because if you look carefully, you will see that now the component can leverage the change detection. With the change detection on push, you're limiting the things that Angular needs to check. I mean, when you leave Angular on the default way, Angular checks many things in order to keep the previous application updated all the time. Sometimes you don't need those many checks. You can reduce them. And using Async pipe, you can reduce it, because one of the things that I check when you're using the change detection strategy and push is the async. Whenever the observable that's bound to the Async pipe emits a new value, Angular will detect that change. So you don't need to use a broader approach. That makes the application much more reactive, much more snappy, much more fast. You can, because Angular needs to check less things. So it makes it a more performant application in the end. So it's another extra advantage that you can leverage using the Async pipe. It's not only making your code easier to read and easy to maintain, and also makes it more performant. So I think it's a very, very great way to approach observables. I mean, I think it's great. I mean, it not only makes your life easier, but also at the same time makes your application even better. So why not, right? And also an extra benefit of using this is you can work with several streams using the RxJS operator. For instance, in your service, imagine you're working with a REST API and you have some data from one endpoint, another data from another endpoint, but you want to display all that all together in your component. You could just use RxJS operators in the service so that it emits one observable, and that observable could be bound to the results, and this recipe will still work in the component. So you wouldn't need to modify really the component in order to show your data. You can do that on the service using RxJS operators, and you will ensure that in the displaying component, all the data will still be available and with the same advantages you had before. While if you're working with subscriptions, you might need to get inside the subscription, manipulate the data, subscription inside the subscription, so it can be more complex. But that way, if you combine the streams in the service, you can still output one observable, and this recipe will still work. So you need to change the component, even if you change the service to get the data. So that's another advantage. So that's the first part of working with observables in Angular in the components using the Async pipe. I think that's very, very easy to work that way when you learn to think in reactive ways. You don't start to think, you don't micromanage Angular, you let Angular handle things. I think that once you get used to that, you start working that way, and it's much faster way to produce results. I'm not sure if anyone has any questions so far. Nope.
No.
Very good.
I was just putting a note in the chat to say that when I first started using RxJS, I didn't know about any operators. I didn't even know there were operators. So I thought I had to subscribe, then change all my, map and filter, and then create a brand new observable with the. And then somebody showed me observables, or operators, and I was like, oh, that's so much easier. I was a dork back then.
I had that kind of enlightenment moment when I saw someone using the fork join operator. Like, what? You join all together after all the meetings and you just outputting one single thing all together. Wow, you can do that. That's amazing. So, yeah, I think we've all been through that.
Rob has a question. Come on, Rob.
Yes, maybe you can talk a little bit about how can we modify the async values, right? Because sometimes we want to touch it, or want to inspect it before we display it, so or modify it in any way. So here in the template, right, we have the async, right?
Yes.
But you cannot really touch this, right? Because it keeps on, updating itself, and also it gets unsubscribed by itself, right? Because of the async pipe. So
right.
Show us the way that you can modify these values, right? Even though we have an async pipe here, we can still modify the values, right?
I mean, you can work with them because what the async pipe actually is, it removes the observable cover. So if you have, like, in this case, it would be an any array. You can do anything you can do with an any array, you can do it there. If you really want to manipulate the observable before, that's where you should be using the operators. I mean, depending on what you need to do, you could use, instead of doing the data right away with the result, if you want to do something with that, you would use a pipe, use the RxJS operators in order to manipulate that observable the way you want it. And once you have it the way you want it, you just expose it outside.
Okay.
I'm not sure if that's more or less what you were asking.
Yeah, in a way, because here in this way you cannot manipulate the data, right? So that's one of the disadvantages of using async pipe.
Because I mean, I like to expose it in the way that I really want it. If I need to change it, I prefer to change it before exposing it outside. However, I'm not sure if it helps. You can use it sometimes like an ng if the observable exists, a sim pipe, and then you use as name it, and you can name that value as a variable. You can use that throughout all the DOM with
Yeah,
that
that's what I
variable
was.
name.
That was what I was
So
getting into. So that for you to explain
you
that,
can do that.
you know, that change, right? That needs to be made in order for you to inspect the variables before it's displayed, right? Or
You can do that, yes. You can do that as well. But if it's something deeper, it's a change that's going to be deeper than that. I rather work with it with the operators before exposing it outside. But once you have it outside, you have the same possibilities you have as if it was outside the observable. Like pillbox, you see the observable is wrapping the any array. Once you apply the sync, you're just wrapping it, and you can do anything you can do with the type it is. That's also why it's important to type things correctly. So when you get things from a stream, you can, with the HTTP client, you can use the get method. The get method allows you to get from a URL right away, but it also has a generic type. So if you use the generic type, then you can use a specific typing in there, and the observable that you get from there will be an observable of that type. That's why it's also important to use correct typing when working with observables, because that allows you to manipulate the things inside the observable correctly. So I think it's a combination of various things. That's more or less, I think, what we wanted to know, right?
yes, thank you.
You're welcome. Any other question?
No, but I just want to say you're doing awesome. Keep going.
I don't know. I don't see myself, which I guess is good. So next step would be subjects. Okay. At first, I remember when I started learning React.js, and I had enough with observables, and someone told me, but there's more. There's subject. I was like, why? Why do people keep adding things? I'll try to explain why we want to use the subjects. Okay. And the difference is between subject, because I think that sometimes we default into using what subject because we don't know what the other can do. So I think the major use case for subjects is when we want to multicast information. Multicast information is the opposite of unicasting. Let's say, imagine that instead of having this meeting, this conversation, I'm calling Tom, and Tom will think, God, what have I done to deserve this? I'm calling Tom to explain this talk to him only. If I talk to him only, I'm unicasting information. I'm sharing my information to Tom only. No one else would know about it. But if I'm speaking in a group meeting, if I'm spreading information around, I'm multicasting. So I'm sharing the information between different people. The same thing works with subjects and observables. Normally observables, there are hot and cold observables. I'm not gonna get into that, but normally observables tend to be unicasting. For instance, if you have an observable that emits a random number and you subscribe to it, the first subscriber will get one number. And if a second subscriber subscribes to that same observable, the second subscriber will get a different number. So it's a different value for each subscriber. But there are times when you want to share the same value to different subscribers. That's where subjects come into play, and they're very helpful in that. I like to think of subjects like antenna radios because they are emitting information all around. It's just sharing information between everyone who's listening. And I think that analogy has helped me understand how to use subjects. So once we have that clear, whenever we want to use to share information, it's a good starting point to think of subjects. There are principally the most known subjects are the subject itself, the plain subject, and the behavior subject. I think most people tend to use behavior subject by default because it always works somehow, and they don't use the subject because people doesn't seem to understand why it's not working. I'll try to explain the difference between them so you can see when to use one and when to use the other one. So a plain subject, which is the one that's type subject, is an Reactive class that's at the same time observer and observable. What does this mean? It means that as an observable, you could subscribe to the subject and receive data. But at the same time, being an observer, you can provide new values to the subject. Normally via the next method, you just call, my subject.next, my next value. And that way you're providing a new value to the subject. And at the same time, that subject can multicast the information to several different subscribers at the same time. But when you're using subject, the subject shares those values to the subscriptions that are active at that moment. That means that if someone subscribes to that subject after it has emitted, that subscription will not get any value. Okay, so if you don't want new subscriptions to receive previous values, you may use a subject. If you remember, for instance, earlier when I was talking about the declarative ways of working on observables, I used a plain subject because I didn't want any new value emitted. Because if that happened, it would kill my subscription before it ever happened. That's a case when you want to use subject, and you don't want a new value right away. You just want to wait for the next value. That's when the plain subject is a very useful case. But there are other cases, however, when you always want to keep one value available. For instance, a case is when you're trying to manage or begin to manage the state of the application. You always want to provide one state, one available value. For that reason, it's very convenient to use the behavior subject. The behavior subject is a specific type of subject that has the same properties like the plain subject before. So it's an observer and it's an observable. So you can pass new values to this observer, and you can subscribe to this one to get values from it. The advantage of this, well, before we go into the advantages, one of the particularities of the behavior subject is that it needs a default value, because the behavior subject will always emit one value. It will either emit the default value if no emission has happened yet, or it will provide to the latest value to the new subscriptions. That's why it already has a buffer of one value. Let me think how to exemplify that.
While you're thinking about that, there's a hand up.
Excuse me?
Yeah, I just had a quick question. It's just want to confirm what I think it looks obvious to me. If there is a later subscriber that comes along after the default value has been emitted, then that later subscriber will not get the default, but they'll just get whatever the last one emitted was. Right?
Exactly. Yeah,
Okay.
exactly. I was going to give an example of that. Imagine you have a behavior subject that emits a value of 10, then emits value of 20, and then emits value of 30, and then a subscriber comes into play. What value will get that new subscriber? The latest one, right? You get 30,
gotcha.
right? And imagine that another subscription comes into play. That second subscriber, what value will get? 30 again, okay? And here comes the cool part. If the behavior subject emits now 60, both previous subscribers will receive now the value 60. Okay.
Mm-hmm.
So they keep updating. The advantage of behavior subject is it always provides you a value. For instance, if instead of being a behavioral subject, it was a plain subject, the two late subscriptions wouldn't get the 30 value ever. They will only get the 60 that was emitted later on. Is that clear?
Yep, makes sense.
Yeah.
Thank you.
Yeah. You're welcome. So that's one. And the next part is more like an anecdote than anything else, but at my work, I have to teach some of my colleagues who have been working for all their life with COBOL, and they're learning Angular. So you can imagine the fun times I have. And I was telling them about using services instead of using inputs and outputs. And one of my colleagues comes and says, hey, I managed to do that. I can do that with services. Look, I'm subscriber to the event emitter. I'm like, what? How is that possible? Yes, and it works so perfectly. I'm like, what did he do now? So I checked out inside the Angular code program, the code itself, and I found actually that event emitters extend the subject. So I think it pays a good reward sometimes to look under the hood, because you start clicking the pieces together. So in truth, when we're using the event emitter and the output, we're actually using our JS under the hood. We just don't know. So I think it's just a curiosity, but I think that sometimes if we scratch a bit of the surface, we can find some cool things. And that's one of the things I like about Angular, because it allows you to scratch, to keep digging. You can find cool things like that one. Obviously, I had to tell my coworker to please use subjects instead of event emitter to subscribe to things, but it was a cool discovery. So I will give you an example of how we could use behavior subjects to communicate with the components. I have the Stacklex application. I'm not sure if I can share the link in the chat without breaking this. I don't see the chat. Well, anyway, I will pass it later on the chat if you need. But it's basically a very basic application that has a service to provide a list of products and a subject to keep updating the amount of products in the cart. And the cool thing is that it updates the amount of products of the cart, both in the header and at the same time in a component. So how will we use that? So an example would be, in this case, we'll create a private subject. In this case, it will be a behavior subject because I want to always provide a value, and for default, I define that this value is 0. I also define it private because I want, since the subject can be modified via the next method, I want to make sure that it can be only modified inside the product service. That's why I use a private. And I expose it to the rest of the components, converting that subject to an observable via the asObservable method, okay? And then I have a method here that takes advantage of the get value. I mean, it's a very crude example, but it works. You get the value of the subject via this method, and I just pass it next with the current +1. You just have an example to see how it works. So this uses the same recipe in the components as you would use it with the Async pipe, because here you have an observable. So in the component, this is a header component. You link the total in the component with the service in total, and you expose it in the template with a Async pipe right away. And you do the same thing with the product list component. You just link the service to the observable in the component, and you can expose it in the template with the same pipe as well. And in order to update the value, you can call the method from the service in the component. That's it. And this way, you are updating both components at the same time. Whenever I call the add to cart, the value in the header component updates, and the value in the product list component updates at the same time, without having to go to, I'm outputting the value and then I'm inputting the value and all those things where I'm calling the service to get the updated value. It updates right away, I think. And I think that's a more effective way to keep your application in sync and update it at the same time. And here we will be starting to get into state management of the application, which I think it's way out of the scope of this talk. But sometimes a behavior subject can provide you the tool that you need without getting into more complex frameworks in order to keep the state. Sometimes a behavior subject does the work and you don't need anything else. And this would be it for my part. I'm not sure if anyone has any question so far. Anything to comment on or improve on. I'm welcome to suggestions as well.
Great, thanks, Jordi. That was great. I really like the analogy of the undefined. Makes a lot of sense, and also looking at the Angular source can be scary, but it's definitely a good way to poke around, get familiar with bits and pieces. We'll see if anyone has any questions. Follow up.
If you if like an event emitter is like an observable under the hood, then you could do all the operators on it if you had a scenario where that would be valuable.
It actually extends the subject, so you have the subject properties.
Okay.
Some extras. But, I mean, it does work. I saw it working. Trust me, I saw it working. I was like, how did you do that? Sometimes when you don't know things, you discover things like that. I was like, how is she making it work? Because she was writing in the chat application we have. Yes, it works with the event emitter. Like, event emitter? What did you do? So it was a funny moment, but it proves that sometimes we don't know, we just stay on the surface, but it's worth digging a little deeper to see why things work the way they work.
Yeah, that's interesting.
Yeah.
Jordi, I never would have thought this was your first technical talk.
It was, trust me.
I would not have guessed that. You did such a good job. That was so professional. I mean, okay, y'all raise your hands if you agree with me. I'm just curious because I thought that was amazing. See? Look at those hands. You killed it, Jordi.
Well, in that case, thank you.
Hopefully it will not be your last. We're just getting started. You did such a good job.
We're just getting started. That's right. Yeah.
Yeah.
Okay.
Thanks, Jordi. Well, I guess we'll do the traditional come off mute and thank Jordi for his talk.
Yay!
Yeah, thank you.
Jordi, that was great.
Thank you, Jordi.
Yeah, thank you, Jordi.
Thanks, Jordi.
Thanks.
Nice.
Can we just say also, this was Tom's first shot hosting, so good job, Tom, too.
Yeah,
Good
thank
job,
you.
yeah.
Yay,
Yeah.
Tom! Don't forget to start
Yay.
Yay.
Currently trying to figure out how to stop the recording, but I got it.
You got this.